Good day, class. Right now, I want to show us how to charge a gold wave electroscope by the method of electrostatic induction. So go and watch my first and second video. You will see how to charge a conductor by the method of electrostatic induction. Now, first of all, what is a gold wave electroscope? A gold wave electroscope is an instrument that can be used to detect the presence of a charge. Two, it can also be used to determine the sign of a charge. Then three, it can also be used to determine the magnitude of a charge or the magnitude of the charge present in a conductor. I'm going to release another video that can help us show how a gold leaf electroscope can be used to do these three, to determine these three. These three I wrote on the board. So a gold leaf electroscope has different parts with different functions. This is a gold leaf electroscope. This one. Can we see it well? This is a gold leaf electroscope. Okay. And on the gold leaf electroscope, we have the brass cap or the metal cap. Then we have the metal rod with an insulator. It is on the insulator that the metal case is mounted. So this is the metal rod. This the insulator. Then on the metal rod we have the metal plate. This one is more flat than this. But I think this is the best way you can draw it on the board. So this is metal plate, while this is the gold leaf itself, the gold leaf. Let me show us once again. You can see this is the plate. You can see that it's flat. This is our plate. So can you see? The plate is flat. Then this is the gold leaf that's almost turned off. Very, very light. Very light. And it's almost turned off. This is the brass cap. It's a conductor. So this is the brass cap. Then we have an extension, brass what? Rod, which also extends down here. Then on it we now have the what? The metal what? Metal plate. Then this is the insulator. You can see the insulator is on this one now that the metal case is built. And we have the metal case with glass. This glass here is drought proof. You can see it's drought proof. The reason why this glass is made here is the reason why the glass is built into the gold leaf electroscope is to prevent drought, to prevent breeze from carrying the gold leaf, from carrying it. It has broken at the back here, so that's why the leaf is dancing. It has broken at the back. So any small breeze can carry the leaf, so it has to be drought proof. So that's why we use this glass to cover it. So the glass is built together with the metal case. All right. All right, so since you already know the major part of the gold leaf electroscope, so I can show us now how we can charge a gold leaf electroscope by the method of electrostatic induction. So go and watch my first two videos to understand electrostatic induction better. So don't forget that electrostatic induction is a process whereby an uncharged body can be charged by a charged body without making contact with each other. Okay? So, assuming I want to charge this gold leaf electroscope positively, what will I do? If I want to charge this gold leaf positively using the method of electrostatic induction, what will I do? I'm going to bring close a what? A negatively charged rod, maybe ebonite rod. So this is step one again. This is step one. I bring in a negatively charged rod. Don't forget that we have equal number of positive and negative charges on the gold leaf already, and there's little or no divergence between the plate and what and the gold leaf and the leaf. So little or no divergence at all. So by the time we bring the negatively charged rod close, what happens? The positive charges are being attracted towards this end. Most of the positive charges will migrate even from the metal case and from the leaf, they migrate up and they'll be attracted towards there. While the negative charges, let me call here end A, while the negative charges will be repelled towards end what? And B. Don't forget we have equal number of protons and what? And electrons, even on the gold leaf electroscope, as far as it is not charged. Now that I want to charge it, this is what will happen. The positive charges will be attracted towards here. Unlike charges, do what? Attract. While the negative charges will be pushed, will be repelled towards this end by the negatively charged rod. So like charges repel. So this is step one. Now step two, exactly what we did in the first two videos. That's what we're still going to do here. Okay. So this is the insulator upon which the metal case is mounted. Now the next thing is that we are going to etch. See the same process? We etch. Now we are going to etch the metal cap, the brass cap. So when you etch it, meaning you are going to put your fingers. So when you put your fingers, now don't forget that our intention is to charge the gold leaf electroscope positively. So meaning these positive charges will remain, must remain, and these negative charges must what? Must go. So how the negative charges go? They will flow. These are electrons, so they will flow from the surface here, from the end B, through your end to the what? To the earth. This step what? Step two. They flow to the earth. Okay? Bending. Don't worry. So they will flow to the earth. After flowing to the earth, now I will use this one as my step three now. This step three. Step three, you must have removed your what? Your finger. When you remove your finger, what happens? We have that. Before removing your finger, the electrons have already flowed to the earth. So we now have only positive charges on the gold leaf electroscope. All right. So what is now the next thing to do again? We want the positive charges to spread around. As far as this rod is still there, the positive charges on the gold leaf on the metal, the brass cap, will still be held close to point A, to the end A. So if you want these positive charges to be free and to be able to move, so we are going to have step four now. Step four. So you will have to remove the charged body. So when you remove the charged body, what happens? The positive charges can now spread around on the surface of both the brass cap and what? The brass rod, the metal rod, the metal plate, and the gold leaf. And then when that happens, what will happen? As far as we now have positive charges on both the plate and the leaf is the one that will now diverge because of repulsion. The metal plate is too heavy for it to start moving because of charges due to electrostatics. So It is the gold leaf because it's very light. It is the gold leaf that is going to move. So we have repulsion, and as a result of repulsion, there is divergence of what? Of the leaf. So we have successfully charged our gold leaf electroscope positively. So if you want to charge it negatively, you do the reverse. Go and watch my video, please. Thank you, and God bless. Make sure you like, make sure you share so that the video can get to as many as possible. All right.